Okay, so this is a hideous one. This is a prime example of a Math 135 question. Okay, so the idea is simple. We just got to use the L'Hopital's rule until we can actually evaluate the limit. Except we have to do L'Hopital's many times for this one. And as you do more and more, the algebra gets a little bit more complicated. First check, the top and bottom is 0. It is 0, right? So 0 minus 0, because this is 0, the whole thing will turn into 0. So let's use L'Hopital's rule. And the top becomes cosine of x minus, before actually I do that, okay, so this is actually a perfect squared. Okay, so it's actually ln of, right? It's 1 plus x squared. Okay, now that using log I can bring it to the front, and we get okay 2x squared ln of 1 plus x. Okay, so I was able to catch that and simplify that a bit. And if you actually didn't do that and you start differentiating, it's going to get a lot uglier much faster. And okay, so it's very important that you keep yourself organized for questions like this. Cosine of x, okay, let's differentiate now. Derivative of arctangent is 1 over 1 plus x squared. Okay, so let me leave the 1 over 2 at the front. Okay, this I'm referring to that 2 right there. And now let's differentiate x squared times ln of x 1 plus x. It's going to be 2x ln of 1 plus x plus x squared over, if you differentiate that, you get 1 over 1 plus x. Okay. Now let's plug in x is equal to 0 in here. We get 1 minus 1 over 1 plus 0, which is 1 minus 1. The top is 0. The bottom, if you plug in 0 in there and 0 in there, we get 0. So we get 0 plus 0. There's still an indeterminate case, so we can use L'Hopital's rule one more time. Okay. Now some of you might be hesitant because what you have right here is quite ugly, right? So you might be hesitant, I was hesitant, to do more another derivative, even though it's top and bottom separately, but that's what we have to do here. So differentiate the cosine, we get minus sine of x. Okay, and differentiate that, and we're gonna get a minus, okay, we're gonna get I'm using quotient rule here, 0 minus a 2x all over 1 plus x squared. Okay, so that's what we get if you apply quotient rule. Here I'm going to apply the product rule, and you get, okay, we get 2 times ln of 1 plus x, okay, plus 2x over 1 plus x. Quotient rule, we get 2x 1 plus x minus x squared all over 1 plus x squared. Okay, so let's organize ourselves a little bit here. Okay, so the top, minus sine of x, 2 negatives, so plus 2x all over 1 plus x squared. Okay, so 2x. Here we get a 2x plus 2x squared. That's going to subtract with this to give you just an x squared. Okay, so we have a sine of x here. We know that, as x approaches to 0, sine x over x is equal to 1, right? So now we're in a good position to actually divide the top and bottom by x. Okay, so I thought about doing that, but when you divide the top and bottom by x, because of this ln, it causes problems. Okay, because ln of 1 plus x over x is going to be again undefined. So we have to push ourselves and actually apply L'Hopital's rule from here one more time. Okay, first check, it is 0 in top and bottom. So clearly the top is 0, sine of 0 is 0. This 2x causes it to be 0. This is 0, 0, 0. Everything is 0. So we can use L'Hopital's rule. So the top we get minus cosine of x. Okay, so if you differentiate that, we get 1 plus x squared minus x to 1 plus x squared 2x. Okay. Right, so I'm kind of assuming here your derivative is pretty good, okay, because I'm going through the derivative quite quickly. Differentiate that and we get 1 over 1 plus x. Quotient rule, we get 1 plus x minus x 1 plus x squared. Lastly, differentiate the top, you get 2 plus 2x 1 plus x squared minus 2x plus x squared. That's 2, 1 plus x. Okay, all bottom squared. So you get 1 plus x squared to the power of 4. Okay, so let's clean this up a bit here. So divide the top and bottom by 1 plus x squared. We get that goes away. One of those go away, and also one of those go away too. Actually, this should have been 4 here. So if one of them goes away, it becomes 3. Right, that turns into 1. Here too, you can divide top and bottom by 1 plus x. So that goes away. 1 left, 3 left. Okay, so let's clean that up a bit. Okay, so 2 on the top, we have 1 plus x squared. It's going to give you minus 4x squared. So power of 3. Okay, so that's gone. So we have 2 over 1 plus x squared. And here we have 2 plus 2x. 1 plus x. Okay, we have minus 2 times 2x plus x squared. Okay, so surprisingly, if you plug in 0 now, actually everything turns out okay. Okay, so look, half cosine of 0 is 1, so minus 1 plus 2 times, all gone, right? So I was going to simplify these, but anything that's x is going to be disappearing. So we get 1 over, at the bottom is just 1, so 1 cubed. The bottom is 2 plus 2, right? Because x is 0. The bottom here also is 1. Here you get 2 times 1. That's 2. Okay, and this is going to all turn in 0, so we have 0 there. Okay, so we don't get a 0 over 0 case anymore. This is minus 1 plus 2. 4 plus 2. Okay, so you get half times by 1 over 6. 1 over 12. Alright, so that's one of the choices. Because that was a very long question.